You're listening to Behind the Wheels with Doug Mason, Dave Walters, and Mike Yeagley. This is a show where we talk about heavy truck and medium-duty axle-ends. Doug, Dave, and Mike bring close to 100 years of experience and expertise in the transportation business. Join us once a month to learn new things about axle-ends. Sponsored by Alcoa Wheels, the global leader in aluminum wheel innovation.
Welcome to another episode of Behind the Wheels. I'm Mike Yeagley.
I'm Doug Mason.
And I'm Dave Walters.
Today we're going to have an episode on a question that we get a lot around here. It's the differences between steel and aluminum, and also we're going to be touching on different kinds of aluminum wheels. We'll be talking about the differences between forged aluminum wheels and cast aluminum wheels. This is sort of our wheelhouse, for a pun there, but this is exactly what we spend a lot of time talking about, a lot of time explaining to customers what are the differences, what are the advantages, what are the disadvantages of each of these wheel manufacturing technologies. So we're going to just dive right into it, and let's get started. So let's start out with steel wheels. Dave, you want to talk a little bit about steel wheels?
You know, steel wheels are the dominant wheel in North America trucking. I mean, they are, by far the most popular, and, the main reason of that is cost. They're very prevalent in the market. Now, on a steel wheel, the way they manufacture a steel wheel, there are actually two pieces. There's a rim and then there's a disc. So a steel wheel is basically welded together with two pieces, and that's how they make a steel wheel. Then they powder coat the wheel to paint it, and again, it's steel, and then they drill holes, and it's very simply made for the market, and that's why they are very inexpensive or cost-wise to the general public.
Now, Doug, you spent some time making cast aluminum wheels. Maybe you can tell a little bit about the cast aluminum wheel manufacturing process.
Yes, certainly. Yeah, cast wheels, steel wheels, forged wheels, all wheels, fun to make. Cast wheels was the first part of my career, and cast wheels are very interesting. They're basically like making Jell-O, if you want to think of it that way. Very simplistically, you're going to create a liquid that you're going to pour into a permanent mold, or pressurize. Really, that's the main process nowadays. Would be a low pressure casting, they call it, or where they'll actually put pressure onto the bath of the aluminum. It'll then go into the mold against gravity. So that is then put into a permanent steel mold. It has multiple pieces on it. Once that it has cooled, then obviously you open the mold, you extract the part, and then it would go through other processes that we'll maybe discuss later on advantages and disadvantages, where it goes through an X-ray process, or it's looking for particular defects, and then it'll go through typically a solution and an aging process. And we'll hear a little more about that. Forgings do a similar process. They call it age hardening, and that's how you get the strength in any particular aluminum alloy that is age hardenable. And then once it's done with the aging process, it'll go into a machining center where they then turn it and mill and drill until you get to the final shape of the wheel. And at that point, it will typically be painted in many different colors, and in some cases even polished. And we can talk about some of the advantages and disadvantages of trying to polish a cast wheel versus a forged wheel as we go through here as well. But that's very simply the process of how a cast wheel is made.
So now I'll take the forged wheels. We start out, when we're making forged wheels, we start out with a bar of aluminum. We cut it to size, and then we put it into a forge press. And there's a blocker, and then there's a finish press. It's like a multiple forge press operation. And so you start out with a blocker, which makes the wheel into a disc, basically. And it starts out, takes that piece of aluminum, makes it into a disc, roughly, and then you put it into the finish press. It sort of builds up, we call it the skirt, the rim section a little bit, but not completely. And then you put it in the final forging operation, which gives it the shape that looks closer to a wheel. but it still has a lot of additional metal on it. So there's an extra metal coverage. You take that forging, this raw forging, heat treat it, like Doug was saying, the same thing that they do with castings. That's where it really gets its strength. So you still have one piece of metal that has all this strength in it, and then you send it to the machining. And in the machining, they mill and drill it. They get it to the shape of an aluminum wheel, polish it up, whatever needs to happen from that point forward for the customer. That's one piece of metal. That's one solid piece of metal that you're working with there. So that's going to come into play, like Doug said. We'll get into this a little bit more. That's going to come into play with all the different benefits and that you get from aluminum wheels. So now that you have an understanding, a basic understanding of the way these three different wheels are made. Steel wheels, I'm just going to go with steel wheels, are welded together, two pieces of metal, two pieces of steel that are welded together. A cast wheel, it's like Doug said, it's you just pour liquid aluminum into a mold, and then that cools, and you sort of build up your wheel that way. Or forged aluminum, you start out with a solid piece of metal. You heat it up a little bit, but not to melting point, and then you have this solid piece of metal that you're working with through the whole process. Those are the three different ways of making wheels, and those you'll start seeing how that plays out in the different advantages and disadvantages as we move forward. So let's talk about the advantages of each of these different wheels. Doug, you want to talk a little bit about the advantages of a cast wheel?
I can talk about the advantages of a cast wheel. It kind of falls in the middle between steel and aluminum relative to cost. So there is a bit of a cost advantage to going to a cast aluminum wheel over a forged aluminum wheel, but it would be more expensive than a steel. And also some of the advantages that you would have is in the processing of it. It's I'll say, not cheap to set up, but the basic cost to set up a low pressure cast plant would be significantly less capital investment than a steel wheel plant or a forged wheel aluminum plant. From a mechanical properties standpoint, it actually has the lowest mechanical properties, but they would be sufficient to do a pass car, light truck, and maybe even some medium-duty applications from that perspective. The greatest advantage really to the cast aluminum is the cosmetics that you're able to obtain. As you can imagine, if you're pouring a jello into a mold, you can make it anything you want, and that's what a lot of the pass car light truck wheels, you'll take a look, they have all these fancy curves and designs, and you can do that with a casting, whereas trying to do that with steel stamped or even a forged aluminum, although you can do it in a forged aluminum, the cost becomes extremely high at that point. So I'd say that that's the greatest advantage, is its flexibility and styling.
I'm going to just take a moment here and sort of define what mechanical properties are, because I think that's a big part of this discussion, and we'll be touching on that a couple of times as we talk. There's a few different mechanical properties, but the one that I want to talk about mostly here is elongation. Elongation is, we'll say, the bendability or the brittleness of the material, and so how easily is that material elongated? Is it real brittle where when you try and pull it apart, it just snaps right apart like a piece of ice where it doesn't give very much, or does it have a lot of elongation like a rubber band or something? And elongation, the higher elongation you have, it's basically the ability to recover from some sort of stress. And that's going to be a big part of this discussion. And so when you say that mechanical properties are a little lower, what did you mean by that?
Well, we would talk about it typically in terms of like yield strength or ultimate strength. If you were to pull something apart, let's just look at it that way, the amount of load that you have to use or force you have to use, ideally we would say stress as you pull it apart, and it'll start to get to a point. If you had a spring, obviously you pull it and it goes back to its original position, and that in itself, there's no permanent deformation that has occurred. But once you pass a certain point, you now have permanent deformation. That's where the elongation comes in that you were talking about. Right. And as you continue to pull, you're obviously going to break the part. And so the mechanical properties is really how much load can you hold for the cross-section of material that you have. Something that is extremely strong, maybe you only need a quarter-inch diameter to hold a certain weight. But then you go to a material that has more mechanical properties, then you can imagine you need to have maybe an inch or 2 inches of diameter to hold that same amount of weight. I don't know if that helps explain it better, but that's what I mean by mechanical properties.
Very good. The big advantage of cast wheels is going to be, the biggest advantage is, of course, the formability. You can make it look however you want. It's going to look great. That's why they hold up pretty good with large loads, and they're relatively cheap. It's perfect for an automotive application. But those mechanical properties starts getting to be a problem. Those lower mechanical properties start to be getting a problem on a heavy-duty application. What about steel wheels?
When I talk about steel wheels, the first thing that comes into your mind is the cost. Being the lowest cost wheel in the market, that's their big advantage. If you talk to a lot of the fleets, they'll tell you the other big advantage of steel wheels is they don't seem to be stolen very much because they're very low cost and it's pretty much, the industry standard. So you don't have to worry about anybody stealing your steel wheels because that's not what they're going to do. So when they have a lot of trailers in the drop and pick and that, the steel wheel looks pretty good because you don't have to worry about somebody coming and taking the wheels off. So it's really cost. And like I said, I've never heard anybody stealing steel wheels. Now they might steal the wheels to get the tires if they're good, but most trailer applications, the worst tires they can find, so that doesn't happen. So it's really a cost factor.
Hey Dave, just a quick comment. I think you noted that the largest volume of wheels would be steel wheels, but that if we break that down between trailer and tractor, don't we see basically a very high penetration on the trailer per what you were saying, and the fact that there are basically 2 or 3 to 1 trailers to every tractor out there. But then from a tractor perspective, isn't there a higher penetration of forged aluminum wheels than steel wheels? Is that correct?
Yeah, absolutely. I mean, the higher penetration of aluminum wheels on the tractors, and there's a reason, because there's normally, one driver per truck, and that truck is, maintained, where when you're running, most of these companies are running 3, 4, 5 trailers per one truck. And if you're dropping and picking and have trailers everywhere and every lot and every place, that's really where steel wheels shine is in the trailer market.
All right. So really, the big advantage for steel wheels is cost, and the anti-theft benefits are really a fallout of that. Anybody want to take the advantages of forged aluminum wheels?
I can do that. I always tell every training session I do, I say, look, I'm not a professional sales guy, but I'll tell you why you should buy aluminum wheels. And the first thing I always tell them is it's actually the strongest wheel because it's a forged aluminum wheel in the market. And it's also the lightest wheel. And those are two big advantages for most of the customers that we deal with. They want strength and they want lightweight. Forged aluminum wheels can do both of that.
One of the big problems we have, and I did a lot of traveling in overseas, and I had all sorts of problems where people would look at aluminum wheels and equate them to aluminum cans that you could crush with your hands. And they didn't quite understand what was happening there, that aluminum, just because it's aluminum, is not weak. And we had to pull out some data. We're getting back to those mechanical properties. The benefits of the mechanical properties of forged aluminum wheels make them unbelievably strong. It has the high yield strength that Doug talked about. It has great elongation, so it bounces back to its original shape pretty easily. And so what you end up with is these wheels, like Dave was saying, where they're very light and they're very, very strong. As a matter of fact, we see, and Dave, you might want to talk a little bit about these high-load applications that are flipping to forged aluminum wheels for exactly that reason.
Yeah, and I mean, it's funny. I'm sitting here in my office and I'm looking at, like a triaxle coal truck in Pennsylvania. And when I remember I have the picture of the very first one we converted. And now I don't know one in Pennsylvania and a lot of the coal hauling states that don't have aluminum wheels in all their triaxles. And that's a very heavy application, and it's a severe application. They're going off road, they're going on road, they got a lift axle, they're picking that up, and aluminum wheels is standard now. So we do really well in severe applications. They're lightweight, so they can haul more payload. So that's really like some of the big advantages. Then we get into, because they are fully machined, the runouts and the balance of an aluminum wheel is tremendous compared to a steel wheel. So we get into those issues that's great. Aluminum can also dissipate heat at a better rate than what steel can. So you can dissipate the brake heat and get it away from the tire and that. So a lot of transit bus industries would do heat studies, the difference between aluminum wheels and steel wheels, and found out that certain tires were getting so hot because of the steel wheels, so they went to aluminum wheels as their general spec. So I mean, the dissipation of heat is a thing that most people don't think about. And there's some great advantages of aluminum wheels, where the steel wheels, when you get into refurbishing costs, it used to be a lot cheaper. Powder coat paint is not cheap to refurbish a steel wheel. Aluminum wheel, you don't really have to ever refurbish it. So, I mean, there's a lot of advantages on forged aluminum wheel.
Yeah, you make up another point, Dave, that we didn't talk about really for forged aluminum. We kind of mentioned in cast, you get this, the cosmetic benefit in terms of shape, but forged aluminum wheels are typically made out of 6000 series alloy, which when polished bring a very bright shine. And so for the customer who wants that, bright bling look on their vehicle, now we have different tastes out there, obviously, but this is one product that'll allow you to give it that high look and that high shine. And I think that in some ways is part of the reason why there's like a better resale value typically with aluminum wheels. The fact that they are aluminum and maybe they're worth more, that also gives you a good resale value on the truck and the way it looks. But there is the cosmetic portion that is a good advantage for the forged aluminum wheel as well.
You touched on the resale, because I deal with a lot of truck dealerships, and they'll tell you that aluminum wheels maintain. There's not a second owner that comes in, and I heard it best the one time. He's like, look, the second person buying that truck is so important. If it has aluminum wheels, they're getting some value out of that. The payback is tremendous because it holds the market. And these guys want aluminum wheels on that second. So resale is a giant value with aluminum wheels.
One of the things you brought up that is counterintuitive to a lot of people is the heat benefit. And so I want to talk a little bit about that and just my experience with heat and aluminum wheels and steel wheels. We did some testing years ago, and Dave, I think you were part of that, where we put thermocouples all over the wheels. We did a lot of start-stop, and I believe it was a trash hauling sort of application. And what we saw was that the steel wheel held onto that. After they parked the vehicle, the aluminum wheel was able to dissipate that heat very quickly. That built up over the course of the day. But the steel wheel held onto that heat even after the vehicle was stopped. And you saw that heat, the temperatures rise in the lot. And so the tires and everything was just sitting there cooking out in the lot because the steel wheel was not able to give up that heat very quickly. And one of the great things about aluminum wheels is they do give up that heat very quickly. And so you end up having a better overall system. It all comes down to heat damage to anything is a matter of time and temperature. So when you're sitting there, when it's sitting there cooking in the lot after a day of running, that's going to cause problems. Like I said, everybody knows that aluminum transfers heat better, and so a lot of people will say, hey, aluminum transfers heat, it seems like it would get hotter than steel. It's going to take that heat away from the brakes and everything else that's happening very easily. Why do you say that heat is a benefit? And really the big benefit is when it's sitting after it stops and it's sitting in the lot cooking, and the aluminum doesn't cook. It gives up the heat real quick, and the whole system is cooled down relatively fast.
I mean, I've done, over my 32 years here, every heat study that we've ever done with the transit and with the waste haulers. And the reason that they're so critical, an average waste truck and residential stopping 600 to 700 stops every stop. you're out in Phoenix, Arizona during the summer, you're going to have some extreme heat just to start with, and then stop that truck that many times. So when we did these studies, they were basically going through tires because the tires got too hot and they cooked the bead. So a lesser degree of wheel basically was saving tire life for these refuge haulers, and same with the bus transit because they're stopping like that. So a normal over-the-road truck doesn't near have the brake heat. You know, we can say, hey, coming down out of the Rocky Mountains, you might heat up, but those guys are every day just stop and go, stop and go. So
Right.
very used to the industry.
And that was to your point, Mike. You were saying basically about the conductivity and how rapid the aluminum can conduct the heat. And I think I was looking at those studies, Dave, and it was interesting is that the steel, obviously, as it begins to heat up and the stops continue to go, it can't reduce the heat as quickly as the aluminum. And so its peak temperature was always higher than that of the aluminum going through the same run. In addition to what you're talking about, Mike, where when it's stopped, it continues to rise or hold the heat as well for a longer period of time. So you had a peak temperature situation as well as the time, and you would note that it's time at temperature, which really creates damage in components.
So let's talk a little bit about the disadvantages of these different technologies. Who wants to take on cast, the disadvantages of cast?
Yeah, well, I can do that. That's, again, my field from a previous life. And really the disadvantage, we said one of them would be it is the lower mechanical properties, but it's adequate for the usage that it's intended for typically. But what you run into and why you can't get into the higher loadings with a reasonable weight is because in a casting situation, you have what they call a casting defects. You get porosity, and there's ways to mitigate that, but you always have some porosity, you always have some inclusions, and these things reduce the fatigue life of a component. So there are incongruities, we'll say, within the material that can be reduced, and there's many ways that it's done. I used to work on how to create a inclusion-free casting, which is not possible, but you can really improve them, but they still come in at a lower basically mechanical property and a lower fatigue strength or fatigue life component. And so that would be the main disadvantage to the casting, because you can get everything else. You can get a pretty high polish. It's not as high a polish or a high luster as you would see in a forged aluminum. The 6000 series just has more copper. It has a better ability to shine, but you can make them quite shiny. And then you can obviously paint them any color with all contrasting colors. And you see that in the vehicles today, two tones, and they get into claddings and partial claddings and all these unique things that they do in the pass car and light truck, which when you get to the heavy truck, basically we really want the lightest that we can get for the lowest cost at the best benefit and the brightest. So that would be cast wheel disadvantage, basically.
One of the big disadvantages I've seen with cast wheel is impact also, and that comes from those mechanical properties we talk about so much. And there are some tests that are industry tests where you basically just have the wheel sitting on the stand and you drop a load on it, you drop some sort of weight on it. And when you do that with a forged aluminum wheel, it'll bang it up, but the wheel pretty much keeps its shape. It doesn't really have too much trouble with it. I don't think we've ever failed that test. It's a very easy test for us to pass, I should say. The cast wheels, when you do that same test, they just explode. We did that test with some wheels, and it was one of the earlier ones that we did years and years ago. We dropped this load onto the wheel, and pieces of the wheel were flying out into the parking lot of the test lab. They went 30, 40, 50, 60 feet away. Luckily we didn't hurt anybody, and luckily we didn't destroy any cars with those wheel parts that were just flying everywhere. It was like a bomb went off. And that's one of the big problems with cast wheels is that impact resistance. They just don't have it. And that's something that is very dramatic to see.
Yeah, and let's make sure we clarify this. We're talking in the heavy truck industry, and we're talking about extreme weights, because in the pass car light truck, they do have impact testing as well, and the ability for a cast wheel to pass those loads, it's capable. It's when you get to these very high loads that we need for the medium duty and really the heavy duty market that what you're saying takes place.
Right. Yeah, I don't mean to strike fear into people about their auto wheels. There's no concern there. But when you get into those high loads that we're seeing in the heavy truck industry, then impact resistance of a cast wheel really becomes an issue. So let's talk a little bit about the disadvantages of steel.
When people talk about steel wheels, they always talk about runouts. And runouts, because you're technically welding two pieces together, the runouts are so much greater than what a forged aluminum wheel is that there's a big difference on runout. And so people will always say, well, what does that mean? Well, your steer tires are your most expensive tires on the truck. And, do you want them actually running as true as possible? Well, with a steel wheel, that's runout is definitely an issue. So we talk about runouts. Then we get into the refurbishing because we live in a very corrosive world because of some of the de-icing equipment and solutions that they use. Unfortunately, with steel, you're going to have corrosion, and then you're going to send it out to a refurbish shop, so you have a cost. And when you go talk to the fleets and you keep saying, here's the cost of this mounting up, I mean, you can run the numbers and say, wow, if I'm going to keep that wheel for a certain period of time, this just doesn't cost justify having some of that. So those are some of the bigger issues, disadvantages of the steel wheel and the weight. I mean, it's a very heavy, they've done a remarkable job taking weight out of steel wheels, but it's still so much heavier than an aluminum wheel. You can add up, some pretty good weight. So those are some of the big disadvantages I see.
Really have to tip your hat to the steel wheel guys. The weight they've taken out is remarkable. They've done a great job there. Even with the work that they've done, it doesn't approach aluminum, but they've done a lot. Understanding the technology that goes into that, it really is remarkable. The one point I wanted to bring up was the runout. We did some testing years ago. We showed the runout of an aluminum wheel versus a steel wheel. If you can imagine, the runout is basically a measure of how round a wheel is. And so what this test did was it measured a circle. If it was a perfect circle, it would be a perfect wheel. And any variation from that, any place where the wheel got a little bit out of round, the line sort of wandered from that perfect round one. And when you looked at an aluminum wheel, Alcoa wheel aluminum wheel, it was perfectly round. It came out of it was, tiny variation from the perfect round. But when you put the steel wheel, they measured a steel wheel, and this was a well-made steel wheel. This wasn't a Chinese. There's some really bad Chinese steel wheels, but this was a pretty well-made steel wheel, but it still looked like it was a flower or something. It was all over the place. The line was coming in and out and in and out of that perfection. And that comes down to, like Dave was saying, the welding process. It's very, very difficult to maintain that perfect roundness when you have to weld these two pieces together. That's what they were struggling with, and that's why it has that run-out problem. Who wants to take on the disadvantages of aluminum wheels? Doug, you want to touch on that one?
Yeah, and add another comment too that maybe roll into it. For the steel wheel, and I think you mentioned a little bit of this from a maintenance perspective, the painting of a wheel, obviously it can be in chip or to rust, and that creates issues in the mounting surface. So there needs to be attention paid to that area of a steel wheel in more detail, and like you were saying, Dave, it creates the need for the refurbishment over time that has to take place. In an aluminum wheel, that is much reduced, but there is still a need to maintain wheels in general, to take a look at how whenever they're mounted, dismounted, when they have tires removed, you do an inspection, you do a review. And so I guess a disadvantage would be that it's not perfect and you still have to work on it. That would be a disadvantage. But I think the greatest disadvantage, unfortunately, and we continue to work on this all the time, is the cost of a forged aluminum wheel. It is the most expensive, and that has to do with all of the processing variables for doing a forged wheel, the capital that's involved, and the cost from the polishing or the finishing perspective. And so that would probably be one of the biggest disadvantages for the forged wheel that we're always working with and trying to offset with the advantages, obviously, that we see in a forged aluminum wheel.
I think that covers it, everybody. So we talked a little bit about the different manufacturing processes. We talked about the advantages of each one of these technologies and the disadvantages. Hopefully, with this information, given your specific situation and what you need for your application, I'll be frank, like we said, sometimes steel wheels make the most sense. If you're in a trailer application, sometimes that's going to make the most sense. Other times, aluminum wheels are going to make the most sense. And like in automotive, and some cast wheels make the most sense. So hopefully we've learned a thing or two when this is what's best for what situation. If you have any questions, drop us a line. You can catch us on the Alcoa Wheels website. I think that's all we've got for today. Thanks for joining us. We'll see you next time.
Sponsored by Alcoa Wheels, the global leader in aluminum wheel innovation, manufacturing, and technology. Inventing the first forged aluminum wheel in 1948, its team of experts continue to develop the most lightweight, efficient, and high-performing commercial vehicle aluminum wheel products. Bringing you revolutionary innovations like Alcoa DuraBrite wheels, Alcoa DuraBlack wheels, the new Alcoa Wheels hubboard technology, and the lightest truck wheel on the market, Alcoa Ultra One 22.5 by 8.25 wheel. Alcoa Wheels, the global leader in aluminum wheel innovation.